Hello viewers, welcome to our YouTube channel. So in this series of video lectures, we are going to discuss about chapter by chapter for few concepts. Okay, so the first chapter under consideration is inverse trigonometric functions. So let us see to this particular chapter. So whenever we talk about the inverse of a function, so inverse, when does the inverse exist? The inverse of any function exists if and only if the function is 1 1 and it is onto, means that is, we can also call it as bijective. So whenever the function is bijective, we can find out the inverse of that particular function. But now if we talk about the trigonometric functions, basically let us talk about sin x. Clearly sin x is not bijective. Why? Because f of 0 is 0, again f of pi is 0. It's not 1 1. Moreover, what is the range of sin x? Range of sin x is confined between -1 to 1, whereas the codomain of sin x is all reals. So in this particular situation, sin x is not a bijective function. I think this point is clear. In this situation, it is not a bijective function. Moreover, all the 6 trigonometric functions, they are many to one functions. It means their inverse we cannot calculate. But now, if we restrict the domain, that is, if we are talking about a function between minus pi by 2 to plus pi by 2, in this situation, if we are defining and we are restricting the codomain as -1 to 1, and if we talk about f of x is equal to sin x now, so we have to understand that how is this function going to behave now. So between minus pi by 2 to plus pi by 2, we can see this is the graph of the function. And in this situation, if we are defining the range is -1 to 1 and codomain is also -1 to 1, which we have defined ourselves. Okay, and the domain that is from minus pi by 2 to plus pi by 2, if we are drawing about, if we are talking about sin x, we can see sin x is extended, but now we are just talking between minus pi by 2 to plus pi by 2. In this situation, f of x is a bijective function. In this situation, it is a bijective function. Okay, since it is a bijective function, so we can calculate the inverse, that is y is equal to sin x. It means what is x? X is nothing but sin inverse of y, right? And our students know it very well. If f is a function from a to b, so the inverse is also a function, but it will be from b to a. So basically, f inverse is defined from b to a, and what is b? B is nothing but -1 to 1, and what is a? A was nothing but minus pi by 2 to plus pi by 2. In this situation, we can see that is what is your f inverse? That is nothing but sin inverse x. Yes or no? And now let's talk about what is the graph of this function. We know it. One more thing, our students know it very well. If we are talking about one function, let us assume log x. Okay, we know what is the inverse. Inverse is nothing but e power x. And if we draw these graphs, y is equal to log x graph is this, base greater than 1, and again base greater than 1. So e power x we are defining like this. Okay, so if we talk about a line y is equal to x, our students can see it very clearly that y is equal to fx and y is equal to f inverse x. They are mirror images of each other about the line y is equal to x. So all what we need to do is between minus pi by 2 to pi by 2, if we insert a line that is y is equal to x, so we have to draw the mirror image of the graph. The graph will look like this in the first quadrant. In the third quadrant, it will look like this. And what are these points? These points corresponding, so this is -1, this is 1, and what is this? This is minus pi by 2, and this point is again plus pi by 2. This is the graph of y is equal to sin inverse x. Okay, now some conclusions which we can easily depict from the graph is, number one, the outputs, they are angles. Outputs are angles, right, between minus pi by 2 to plus pi by 2 in this situation. Okay, number two, our students can easily understand that the graph is symmetrical about origin. Graph is symmetrical about origin. We know it very well. If the graph is symmetrical about origin, it means it is symmetrical in the opposite quadrants whatsoever the shape is in the first quadrant, same kind of shape is in the third quadrant. It means f of x is an odd function. It's an odd function. Since it's an odd function, so we can say that sine inverse of minus x will be minus of sine inverse x, right? So that will be minus of sine inverse of x. We should understand this. Okay. Number 3, we can see f of x is continuous. The graph is not breaking anywhere, so it is a continuous function. Number 4, f of x is non-periodic function. It's not repeating. Okay, f of x is non-periodic function. Okay, and number 5, we can also see the graph is of the f of x is bounded. Okay, whenever the range is bounded, we'll say the function is also bounded. We can see the graph is bounded, right? So these are some very nice conclusions which we can draw. One more interesting conclusion which we can draw from this graph is f of x is an increasing function. Increasing function. What is the meaning of increasing? With the increase in values of x, we can see the values of y are also increasing. As x is increasing from -1 to +1, y is increasing from minus pi by 2 to plus pi by 2. So we can easily say that the function f of x is equal to sine inverse x is an increasing function. Now let us take few examples. For example, if somebody asks us what is sine inverse of half, sine inverse of half, so it means, from b to a, otherwise we can think, or we can see, when the input is half, what is the angle corresponding? Okay, so yes, it is 30 degree. 30 degrees means pi by 6. So one thing which we have to understand here is sine inverse x does not means 1 upon sine x. Does not mean 1 upon sine x, clearly, because if we put x is equal to half, sine inverse half is pi by 6. Pi by 6 is not equal to 1 upon sine half. That is not the meaning, right? So one thing we have to understand, that inverse does not means 1 upon. Okay, that is another independent function. Okay, I hope this point is clear. If we talk about sine inverse of 1, if somebody asks you what is sine inverse of 1, we can see from the graph also it's pi by 2. Otherwise also we can think also in the same way. Sine inverse of minus root 3 by 2. So clearly sine inverse of minus x is what? Minus of sine inverse x. So just send minus outside and just focus on sine inverse root 3 by 2. What is sine inverse root 3 by 2? That is pi by how much? 3. Okay, so that is how we can figure out various angles whenever something related to sine inverse x is being asked. So these are some conclusions and these were some angles which we have defined. Now let's talk about some interesting problems based on this sine inverse x only. Let's talk about a question that is find the domain and range. Find the domain and range of f of x is equals to sine inverse of e power x. Sine inverse of e power x. So you know it very well, whatever the input is there inside sine inverse, that should lie between -1 to +1. This is something which we know. Now we have to understand one thing, very conceptually from this particular point. We know the graph of e power x, right? E power x is like this. E power x is from 0 to infinity. The range is from 0 to infinity, right? 0 open. But now somebody is saying that e power x should be restricted between -1 to +1. This is the point +1, right? So this is corresponding to +1. Somewhere here it is between, -1. So the graph between this is this much. And for which values of x it is true? Corresponding values of x are from -infinity to 0. Yes or no? So it means this thing is only true. This is true only when x lies between -infinity to 0. I hope this point is clear, because when this is the situation, in that particular case only, the graph is nice. Let us talk about 0. 0 should be included or not. What happens at 0? E power 0 is 1, so 1 should be included, right? It's a close 1 in the question itself, right? Close 1, so we should close 0. That is the domain of the function. Now let's talk about the range of the function. For range of function, now we know that exponential function, now corresponding to this domain, that is when x is between -infinity to 0, in that particular situation we can see the range is between 0 to 1, right? Exponential lies between 0 to 1. So when e power x lies between 0 to 1, okay, so what about sine inverse What about sine inverse? The inputs are between 0 to 1. We can go back and check the graph. Whenever x is between, input is between 0 to 1, the output is between 0 to pi by 2, right? So that is sine inverse. We can see like this also, sine inverse 0 and sine inverse 1. Okay, this is a close, this is open, right? So this is open 0 and close pi by 2. That is what the range of this particular function is. So I hope this particular lecture, this particular video lecture is clear to all my dear students. So this lecture was about the, more or less about the analysis of sine inverse x. Now in the next lecture, we will discuss about cos inverse x. For more such videos, do subscribe to our YouTube channel and do not forget to press the bell icon. Thank you so much, students. Thank you.